All right, welcome to the deep dive, everyone. Today we're taking a look at a planet that's it's pretty close to home, right?
Yeah, you could say that.
Our nearest neighbor, Venus. Venus? It's often called Earth's evil twin.
I've heard that.
Yeah, and that's because, it's about the same size as Earth, and they might have been kind of similar way back when.
Yeah, possibly. Yeah.
But now it's a completely different story.
Oh, yeah. Yeah, dramatically different.
Yeah, so we're going to really try to get deep into some of the truly bizarre, lesser-known parts of this planet, focusing mainly on its atmosphere.
Okay.
We'll be looking at some recent research, but also going back a few decades to see what we've learned about Venus.
Sounds good.
Yeah.
So, where should we start with this? It's a planet that, well, it's always throwing up surprises for us.
Yeah.
I mean, it might be Earth-sized, but the more we look, the more we see a world that's just extreme.
Right.
You look at it in visible light from orbit, and all you see is this thick, dense blanket of clouds.
You can't see anything.
Can't see the surface at all. That's why we have to rely on infrared, ultraviolet, and especially radar.
Oh, yeah.
They're the tools that let us peer through the clouds and see what's really going on.
Exactly.
Yeah.
So let's talk about something that makes Venus immediately stand out from the crowd.
Okay.
Its rotation.
Oh, yeah.
Or, well, it's a lack of normal rotation, right? Most planets, they spin in the same direction. But Venus...
Yeah, Venus is the odd one out, isn't it? It has this retrograde rotation, meaning it spins backward compared to almost all the other planets in our solar system.
It's like, picture the sun rising in the west and setting in the east.
Exactly.
That's what's happening on Venus.
And it's not just spinning backward, it's incredibly slow.
Oh, yeah.
One full rotation takes a whopping 243 Earth days.
That's crazy, 243 Earth days.
Yeah, and that has some pretty major consequences. Like, it affects its magnetic field, or rather the lack thereof.
Yeah.
And it really messes with how the sun's energy gets spread across the planet. You end up with these crazy atmospheric circulation patterns, completely different from what we see on Earth.
Yeah, it's like a Venusian day is longer than its year.
Yeah, exactly. The year is only about 225 Earth days.
So how did it end up like this, spinning so slowly and backward?
Well, there are a couple of leading theories that researchers have been exploring. One of the most popular ones is this idea of a massive collision. Early on in Venus's history, imagine a huge object smashing into it and basically changing its spin completely.
Whoa.
Yeah, dramatic stuff. And there's actually been some impact simulations that seem to support this idea. The other interesting thought is that maybe Venus isn't actually spinning backward?
What?
Yeah, but instead it's tilted on its side, almost completely upside down. Like a 180-degree tilt, kind of like Uranus, but even more extreme.
So it's like it's rolling instead of spinning.
Yeah, in a way.
Okay, that's wild. But what could cause a planet to tilt like that?
Well, you have to think about the really long timescales involved in planetary evolution.
Yeah, billions of years.
Yeah. There are probably a lot of factors that play a role. Things like the tidal forces from the sun, the gravitational pull of other planets, especially early in the solar system, and even stuff happening inside Venus itself, like friction between its mantle and core. All these things could have nudged it over, bit by bit, over billions of years.
So it's kind of a cosmic dance.
Yeah, a very slow and complex dance.
That led to Venus being flipped on its side, so to speak.
Yeah, and it could be that this weird rotation is connected to another strange thing about Venus.
What's that?
It doesn't have any moons.
Oh, yeah, that's right.
Most rocky planets have at least one moon. Mars has two. We have our moon.
Yeah.
But Venus is all alone.
It's lonely.
Yeah, and there are some theories that link these two things together.
Okay, how so?
Well, one idea is that Venus might have had a moon once, but after its rotation reversed, this moon, because of the gravitational pull, started to spiral in towards the planet.
Oh, so it got too close.
Yeah, and eventually it got ripped apart by Venus's gravity.
That's kind of sad, actually.
Yeah, it's cosmic tragedy. Another idea has to do with the fact that Venus and Mercury are so close to the sun, and the sun's gravity is just so strong that it could have messed with the orbits of any moons that might have formed around them.
So it's like the sun was being a bit of a bully.
Kinda, yeah.
Yeah.
And there are some simulations of the early solar system that show this could have happened.
So it's like Venus might have had moons, but the sun just wouldn't let them stick around.
Yeah, exactly.
Okay, so Venus is this slow, backward-spinning planet with no moons, but then there's its atmosphere, which is moving super fast.
Oh, yeah.
Talk about contrast.
It's a wild place. While the planet itself takes those 243 Earth days to rotate, Its upper atmosphere whips around the whole planet in just 4 Earth days.
4 days. That's insane.
Yeah, that's about 60 times faster than the planet below. Wow.
And the wind speeds up there. They can get up to 400 kilometers per hour, sometimes even more.
So it's like hurricane force winds up there all the time.
Pretty much, yeah.
And with an atmosphere that dense, I'd imagine the surface winds would be pretty strong too, right?
You'd think so, but actually it's the opposite.
Yeah.
Down at the surface, it's almost eerily calm. The Venera landers, those Soviet probes that landed on Venus, they've measured wind speeds down there, and it's only like 1 to 2 kilometers per hour.
So it's barely a breeze.
Yeah, pretty much. It's like a super thick, slow-moving fluid down there.
That's so strange. So hurricane one's above and a gentle breeze below.
Exactly.
And you mentioned that the superrotation isn't even slowing down. In fact, it might even be getting faster.
Yeah, there's evidence for that.
How is that even possible?
Well, figuring out what drives this superrotation has been a real puzzle for scientists since they discovered it back in the 60s.
Yeah.
They looked at turbulence, different kinds of atmospheric waves, all sorts of things.
But the latest research points to something called thermal tides as the main driver.
Thermal tides. So it's the sun's energy that's stirring things up.
Exactly.
How does that work?
So the sun heats up Venus's atmosphere.
Right.
And it heats up the day side way more than the night side.
Okay.
And this creates big differences in temperature, which lead to big differences in atmospheric pressure.
Right.
And these pressure differences create these huge atmospheric waves that travel around the planet.
Okay.
And these waves, they actually transfer momentum.
Momentum.
Yeah, from the slower moving lower atmosphere to the faster moving upper atmosphere.
So it's like a boost.
Exactly. It's like a constant boost that keeps the superrotation going and maybe even speeds it up.
So the sun isn't just heating Venus. It's actively whipping its atmosphere into a frenzy.
Yeah, that's a good way to put it.
Okay, let's move on to something else that's visually pretty amazing. The Y feature.
Ah!
I've seen images of it, this dark marking that stretches across almost the entire planet.
Yeah, it's really impressive. It's most visible in ultraviolet light.
Okay.
And we've known about it for over 50 years. Mariner 10 was one of the first spacecraft to get good images of it.
And we still don't know what it is.
We have some good ideas, but there are still some mysteries.
Okay, so what do we know?
Well, at first, scientists thought it might just be some weird cloud formations.
Right.
But then they realized that this Y shape moves as one whole structure, and it moves differently from the surrounding atmosphere. So it's not just clouds. We think it's some kind of chemical or substance in the atmosphere that absorbs ultraviolet light.
Which is why it looks dark.
Exactly.
So it's like a planet-sized shadow in UV light.
Yeah, and it has its own distinct motion.
That's crazy. Scientists must have been scratching their heads over this for decades.
Yeah, they've been trying to create atmospheric models that could explain how something like this could form and last for so long.
And did they figure it out?
Yeah, there was a big breakthrough a few years ago.
Okay.
Some researchers published a paper in the Journal of Geophysical Research Letters.
Okay.
And they proposed that the Y feature is actually caused by a giant atmospheric wave.
Wave.
Yeah, a wave that forms near Venus's equator.
Okay.
And the reason it gets this Y shape is because the wind speeds on Venus change a lot as you move away from the equator. They also change with altitude.
Okay.
So the wave gets stretched and distorted into this Y shape because of these changing wind patterns.
So it's like the winds are sculpting the wave.
Exactly.
That's pretty amazing. And it's only visible in a very thin layer of the atmosphere, right?
Yeah, only about 8 kilometers thick.
Wow. So it's like this thin layer where the wind and this wave are interacting to create this global scale feature.
Yeah, it's pretty remarkable.
Okay, let's move from ultraviolet observations to something closer to the surface. Akatsuki has given us these amazing images of symmetrical bands in the sulfuric acid clouds.
Oh yeah, those are fascinating. And they were able to recreate these symmetrical bands in the simulation and matched the Akatsuki images really well.
Wow.
So by comparing the model and the observations, they figured out that these bands are formed by polar jet streams and polar Rossby waves.
Polar jet streams like the ones we have on Earth.
Yeah, similar idea. They're these fast-flowing currents of air driven by temperature differences. And Rossby waves are these large-scale waves in the atmosphere, kind of like the bends in a jet stream.
I see.
And on Venus, these Rossby waves, combined with the jet streams, create these huge swirling vortices.
Vortices?
Yeah, like giant whirlpools of air.
Okay.
And these vortices get stretched and shaped by the jet streams, creating the symmetrical bands in the clouds.
So it's a combination of things: the planet's rotation, the temperature differences, and these waves.
Yeah, all working together to create these stunning patterns.
Venus is full of surprises. Now, speaking of visually stunning features, let's talk about the smile, or bow-shaped structure.
Ah, yes, another one.
It's huge, like 10,000 kilometers long, and it can last for days, even with the super rotation.
It's a real head-scratcher, but we think it's a gravity wave.
A gravity wave, not like the ones from black holes and stuff. Right?
No, not those kind. This is an atmospheric gravity wave.
Okay, what's the difference?
So atmospheric gravity waves are disturbances in the atmosphere caused by buoyancy forces.
Buoyancy forces, like hot air rising.
Yeah, kind of like that. Okay.
It's a different thing from gravitational waves, which are ripples in space-time.
Right. I get it. So how do these atmospheric gravity waves create the smile on Venus?
Well, there's this massive mountain range on Venus called Aphrodite Terra.
Huh?
And it's huge, like up to 4.5 kilometers high.
Wow.
And when the atmosphere flows over these mountains, it gets pushed upward.
Makes sense.
And this upward push creates these gravity waves that travel up into the atmosphere.
Okay.
And eventually they become visible as this bow-shaped cloud feature.
So it's like the mountains are casting a giant wave-shaped shadow in the clouds.
Yeah, that's a good analogy.
Pretty cool.
That's a really new finding.
It's thousands of kilometers long, made of sulfuric acid clouds.
Yeah, and what's really interesting is that they found it in archival data from 30 years ago.
So it's been there for decades.
At least that long, yeah.
So it's not just some fleeting thing.
No, it seems to be a pretty permanent feature, but we don't know why it's there.
Not yet. It's too early to say.
Another mystery for scientists to solve.
Exactly.
And then there are the polar vortices on Venus, which are kind of like the ones we have on Earth. We have these swirling masses of cold air at our poles, and Venus has them too.
Yeah, and sometimes they even have double vortices.
Double. How does that work?
So the basic idea is that warm air from the equator rises up and moves towards the poles.
Okay.
And as it gets closer to the poles, it cools down and starts to sink.
Right.
And because of the planet's rotation, it starts to swirl.
Like water going down a drain.
Yeah, kind of like that. And that creates the vortex.
Okay.
But sometimes, for reasons we don't fully understand, this single vortex can split into two. It might have to do with the way the air is flowing, the planet's rotation, and maybe temperature differences near the poles.
It's like a cosmic ballet.
Yeah, a very complex one.
And we've known about the double vortex at the North Pole since 1979.
Thanks to the Pioneer Venus mission. And then, in 2006, Venus Express found one at the South Pole, too.
Using infrared images.
Exactly.
But that one didn't last as long, did it?
No, it eventually merged back into a single vortex.
So the double vortex might not be a stable thing, at least not at the South Pole.
Yeah, seems that way.
So much activity going on in that dense atmosphere.
It's amazing how much is happening up there when the surface seems so static and extreme.
It's like two different worlds.
Yeah, it really is. And it reminds us how much we still don't know about our closest neighbor.
Absolutely. And it's funny to think how our perception of Venus has changed over time.
Yeah, it has.
Before we sent spacecraft there, people imagine it as this lush tropical paradise. But then Mariner 2 came along and the Soviet Venera missions, and they revealed this incredibly harsh and unforgiving environment.
Yeah, it was a reality check.
From paradise to a scorching hell. And it's not just the atmosphere that's extreme. The geology is pretty unique too, with those tesserae formations, the corona, and the pancake volcanoes.
And there's evidence that the entire surface of Venus has been reshaped multiple times throughout its history.
Global resurfacing events.
Yeah, it's like the planet was repaved.
Wow, that's intense. And it's all because of that thick CO2 atmosphere and the sulfuric acid clouds.
Yeah, they've created this runaway greenhouse effect.
Which has made the surface hot enough to melt lead.
And the pressure is 90 times that of Earth's.
So it's like a pressure cooker gone wild.
Yeah, pretty much.
But even in this hellish environment, there's this tantalizing possibility of life.
In the clouds, yeah.
Yeah, in the upper layers of the atmosphere where it's a bit cooler.
There are these strange dark streaks called blue absorbers that absorb UV light.
Yeah.
And some scientists think they might be related to microbes.
Microbes living in the clouds of Venus.
It's an incredible idea, isn't it?
And then there's the whole debate about phosphine gas.
Right.
Which on Earth is associated with life.
So finding it on Venus was a big deal.
Yeah, even though it's still not conclusive.
but it definitely adds to the intrigue.
And to think that Venus might have once had oceans of water.
Yeah, it's pretty mind-blowing.
The evidence comes from the deuterium to hydrogen ratio,
which was measured by the Pioneer Venus mission.
Right.
And it basically shows that Venus lost a lot of hydrogen.
Which means it must have had water.
Because water is made of hydrogen and oxygen.
So Venus was a completely different place billions of years ago.
It probably had a more Earth-like climate.
But something happened. Something went wrong.
Yeah, and we're still trying to figure out exactly what.
Well, luckily we have new missions heading to Venus to try and answer those questions.
Yeah, Akatsuki is already there, gathering data.
Right.
And then there's Da Vinci, Veritas, and Envision.
All set to launch in the coming years.
They're going to study the atmosphere, the geology, the history of Venus.
They'll be our eyes and ears on this mysterious world.
Exactly.
And we're also learning more about Venus's slow rotation.
Yeah, we're starting to understand how its massive atmosphere and the tidal forces from the sun are slowing it down even further.
It's like the sun is putting on the brakes.
Yeah, in a way.
And then there's the discovery of tectonic-like movement on Venus.
Yeah, but it's different from Earth's plate tectonics.
Right.
It seems like Venus has these large blocks of lithosphere that move around.
It's like a giant jigsaw puzzle.
Yeah, but we don't know how it works yet.
Another mystery for future missions to investigate.
Absolutely.
And it's amazing to think that we've actually landed probes on the surface of Venus.
Oh yeah, the Venera landers.
Those were incredible feats of engineering.
They had to withstand incredible heat and pressure.
Yeah, they only lasted for a few minutes before they got fried.
But they sent back valuable data?
Yeah, Venera 7 was the first spacecraft to soft land on another planet.
And Venera 9 and 10 sent back the first images from the surface.
Those grainy black and white images, they were iconic.
They were. And then there was the Vega mission, which deployed a balloon into the Venusian atmosphere.
Yeah, a balloon floating through that hellish sky.
It's amazing what we've been able to achieve.
And the radar mapping from Pioneer Venus and Magellan.
They revealed the hidden landscape of Venus.
The mountains, the volcanoes, the impact craters, all hidden beneath the clouds.
It's like they peeled back the layers.
And did you know that most of the features on Venus are named after women?
Yeah, it's a nice touch.
From mythology, history, all sorts of amazing women.
Except for Maxwell Montes, the highest mountain on Venus.
Right, that one's named after James Clerk Maxwell.
The famous physicist.
Yeah. And while we can't see into the interior of Venus directly, we think it's probably similar to Earth's.
A core, mantle, and crust.
Just based on its size and density.
Yeah, the model suggests that.
So it's like a twisted version of Earth in a way.
Yeah, a world that could have been our twin.
But took a very different path.
And who knows, there might even be life down there.
And even Carl Sagan imagined a future where we could terraform Venus.
Using algae to transform the atmosphere.
It was a bold idea.
Very bold, and probably not very feasible.
But it shows how much Venus has captured our imaginations.
It's a planet that pushes the boundaries of what we think is possible.
Yeah, and it makes us rethink what we consider to be habitable.
Especially when you think about the possibility of life in those clouds.
Life that could be completely different from anything we know.
Yeah, maybe high temperature life, non-carbon based life.
The whole new realm of possibilities. And maybe some internal factors we don't understand yet.
Yeah, but the lack of a magnetic field makes it even more vulnerable to the solar wind.
So it's like a planet that's exposed to the elements.
In a way, yeah.
And when we talk about habitability, we have to remember that it's not just about the surface.
Right.
There could be habitable zones within a planet's atmosphere.
Like those upper cloud layers on Venus.
And some scientists have even proposed sending aerostat-based research stations to Venus.
Like floating labs that could drift through the clouds and study them up close.
That would be amazing.
It would be a game changer.
It really shows how much potential there is for future exploration. Everything we've learned about Venus, it helps us understand the bigger picture of our solar system.
How it formed, how it evolved.
And how planets can end up so differently even when they start out similar.
It's a cosmic puzzle that we're slowly piecing together.
So as we wrap up this deep dive into the strangeness of Venus's atmosphere, I'll leave you with a final thought.
Okay.
Given everything we've discussed, the bizarre weather, the extreme conditions, the hints of possible life, what do you think truly makes a planet habitable?
That's a big question.
And what kind of weird and wonderful forms might life take in places like Venus?
Something to ponder.
Yeah, and with all the new missions heading to Venus, we might get some answers soon.
I can't wait.
Thanks for joining us on this deep dive into the mysteries of Venus.
It's been a pleasure.
Until next time.